This material is made available to you by or on behalf of the University of Melbourne under Section 113P of the Copyright Act 1968. It may be subject to copyright. For more information, visit the University Copyright website.
Okay, we're ready. So welcome everybody to Programming and Software Development, Lecture 3. As you can see, today we're going to be covering control. But before we go into today's lecture, I just want to overview a few things on the LMS. Some of you may already be aware that the assignment is now open, so you can have a look at the assignment. It's under this assessment section, and you'll find the assignment here. It's due in on the 16th, if you can see that, the 16th of August. It shouldn't give you too much trouble, but if you click on the assignment, you'll have assignment 1. Click on the assignment to download it here. It gives you the script of what you need to do. Again, you have a good few days, I guess, to tackle it. It's not a difficult task. This is just kind of waking you up to the concept of assessments. I hope that everyone by now has accessed the servers. If you haven't accessed the servers, I know quite a few people are nervous about putting their hands up. Come and see me. You will need to access the servers to submit your work. So Lab 1 was all about accessing the servers, setting yourselves up, connecting to Nutmeg or DimeFox, which are the two servers. It's the same domain, but two different servers. And I know there's Nutmeg 2 and DimeFox 2, but we're sticking with the first. You must at this point be able to access those servers, because you will not be able to submit your assignments if you can't do that. So do come and speak to me and get that set up ASAP if you haven't got it already. There was an issue, there's some technical issues that were outside of our control that the IT team were sorting out with the servers. I think a lot of people weren't able to access the servers last week or the week before. I'm under the assumption that those issues are now resolved. But the main feature that many students were having, that if you haven't logged into a university machine, then it doesn't set up your server space. So it doesn't actually set up an account for you automatically. So when you try and log in from home, you'll be getting a rejection because you don't actually have an account. I've put a link up on the announcement section, I believe, so that you can actually manually make an account for yourselves if you haven't already done so. But if you still can't get an account active with this, do contact the IT on the link here. Make sure that you get that done ASAP. Don't come to me on the 16th of August saying, oh, I can't access my account. This is not the time to be doing that. So now is the time to be making sure that you can actually submit your work and that the system is working for you. Okay, so do come and see me after this lecture straight away if you do have any issues, so that we can try and get those resolved ASAP. Any questions on that? No? Everyone happy? Okay, cool. If you're happy, I'm happy. So last week we talked, the previous week, Hello World, and we talked about the import scanner and arguments. For the purpose of the assignment, I'm going to review a couple of things to do with the IDE just at the beginning of this lecture, just to help with your understanding of how it works in an IDE. Naturally, you'll be submitting through the terminal on a Linux server, but if you're working from an IDE, I don't want that to slow you down, because an IDE's job is to speed things up. So I'll show you some examples of what you will need to do to get the arguments and such in, which I'll run through that now, I guess. So if you're going to use your IDE, which I'm going to be using NetBeans, if you're using Eclipse or anything else, then it'll be your job to find out how to do what I'm showing you what to do now. But I just want to review this. I will go into more details on this later. There'll be a lecture dedicated to it, but just for the purpose of your assessment, this argument is an array, as I mentioned before, that takes inputs into the software through the command prompt. When you're using an IDE, you don't actually have a command prompt, so you have to supply that information in a different way. So what we have is every project that you create will have like a hierarchy here. So if you look at the projects section here, this one I'm looking at the moment is this Comp 90041 Semester 2. If you right-click on your project and you go down to Properties, here, I hope that's big enough, then you get this, this little environment here that you can do certain things on. And what you want to do is you want to come down to this Run section, and then where it says Arguments, this is where you put your arguments. So if I put in, say, for example, Thomas Christie here, Christie, so it's seeing that there's two arguments there, not one, even though there's, it's one string to us, right? That's actually two arguments. I'm providing two arguments, and I want to quickly show you how that works. I'll explain this to you later as well. This is something else you'll need to be aware of, but I'll go through that during the lecture. So once you've got that done, what that means is when I run this code now, it's actually going to, so this is in-class code, so let me, I've run the code, nothing's happened because there's nothing in the code, right? You can see there's nothing there for it to do. So if I just do a quick system.out, and I type in args 0, that's now going to access the first element of the array that I'm supplying. And if you remember, I put Thomas Christie, therefore there's two elements there. So what we expect when we run this is Thomas, right? Now if I do the same thing again and put in 1, we will now expect to see Thomas Christie. I hope this is big enough, because if it's, there we are. Ah, that's better. So you can see that's now going through the two arguments, and you can see that it's the arguments will be presented, and it's coming into the application, and then it's being processed and delivered to the output. Now, if we did that again, oops. Oh my gosh. All right. I just want to show you. So if we then go and try and access an element that's outside of that, naturally you'll get an exception, array out of bounds exception, which we mentioned before. So that's the first thing. In terms of your programs, what I would expect you to do is to put in a condition, such as a for loop, and the for loop takes the length of the argument, in this, for each. It'll take the length of the argument and print out, so it'll iterate through the length of the argument and iterate out the actual information you have, or while there's a length. So in this case, it would be for I to I less than args dot length. And this dot length is a function that's a method, sorry, Java terminology, a method that's available for most objects, certainly arrays, that then will iterate through all the arguments. And then if you do the outputs and print out I, you'll see that it'll just, oh, it's not done it there, is it? Print out, what am I trying to do here, guys? Args of I. So I'm going through the arguments of I. It should print out any argument that's there. And of course, if I go to the arguments again and I remove those arguments, so imagine that this part of the code now is in my code, and I remove those arguments that I had in the run section, like so, and then we run the code again. There's nothing that happens. You don't have an error because there's no elements there for it to iterate through. So that's just a useful bit of code to sort of draw in. I'll be running through for loops and stuff today, so don't worry. That's what today's purpose is, so don't be alarmed. Okay, so that's the first thing. I wanted to just recover the concept of the arguments. You will be needed to be using those throughout your assignment submissions. What happens is you'll submit your work, and then we, or I, have a system that runs through a number of tests, and what it does is it provides a stream of different testing arguments or parameters to your code to test everything that needs to be tested, but it does that in the same situation, in the same way, and that's why that's important. I just wanted to also highlight the concept of the scanner. So this is the command line arguments which I was talking about. And also I want to look at the scanner and the next line and the next. I want to show you an example of the difficulties that you can get into using next line and next or next double or whatever when you're actually taking inputs from the user. Okay. So as I mentioned last week, next takes in a next sequence, a next word that is separated by white space. White space is what the space bar, right? Just a gap. Whilst next line takes the entire line. But there is an issue there, because what happens, and I've already created an example in the code, I believe. What's this? Okay, I don't know what I'm looking at here, guys, but the source I have you. Nope, that's not what I'm looking for. Okay, so here I have an example called inputs. It's a function, but what I'm trying to show you is the scanner. So we have an example of scanner. You make a new scanner, and as I mentioned last week, I only use one scanner. There are reasons and things that you can play with 2 scanners or 3 scanners or 4 scanners, but it doesn't work the way you'd expect it to work. So we're just going to be pushing the concept of just making 1 scanner per project. So in this case, you've got a scanner called input. You're asking for a name. You're taking in next. You're doing this again. You're asking for a name on the second run. You're taking in next. And if you remember, next actually takes a token, like I said, a single word. It breaks your entire input into words, takes each word in turn. But the difficulty is that it holds a buffer. So if you put in 2 or 3 words when you're putting in the input and you call next, it takes the first word and it stores the other 2 words in a buffer. And that buffer then waits for the next input and supplies that information when you're not really expecting it. Or maybe you are, if you're that way inclined. Generally, you're not expecting those inputs to be there because you've called next, if you will. So you have to be very clear with how you use that. So what I've done is I've done 3 inputs using next. So you can see next is here, next is here, and next is here, asking for the same things, printing at the same value, so there's no big deal. And then I'm doing the 3 inputs again, and this time I'm calling next line, right? So I'm going to just run this. So I'll do is, you can only have, as I mentioned before, actually what I'll do, I'll call it, I'll go into statics and stuff with you later, but what I'll do is I'll call it, I'll get rid of that, and I'll call, it's called examples, so I'll call it from here. Examples dot, I'm calling the input class. All I'm doing is calling a method inside another class. Don't worry about that. We will go into a lot of detail on that later. But I just want to run this code here. And the reason I've done it that way is because this is where the main class is in this class for this project. And I just wanted to call that main class when I click run. So that's the reason I'm doing that. But I will go into more detail about that. So this is going to run this code. It's going to do 3 next calls of the scanner class. It's going to do 3 next line calls for the scanner class. And what we're going to do is we're going to look at how it interprets that input and how it outputs that input, so that it kind of makes the concept of what I'm trying to explain, makes it settle in your minds. So I'll run that now. Again, so now what it's done is it's run this class called this input. Okay, don't worry about how it's working for now. And I'm just going to put in 2 words, my name, Thomas Christie. And as you can see, immediately it's taken in, it's printed out the first word here, text, and then it's asked for the second input, but because Christie was already in the buffer, it's put Christie in as the input, even though I didn't type it in a second time, and then it's not actually, it's then waiting on the next line, if that makes sense. So I'll do Thomas Christie again. Okay, so this time, let me just make this bigger. Hopefully what you can see is that before start again, I had 3 inputs. It's only asked me twice. The first time it's taken in this Christie, the second input, as its input, and it's done the same thing on this one. So this time I'm going to do it again, Thomas Christie. I guess I could ask you what you suppose is going to happen, but but I'll just move on and show you what's going to happen. But it isn't what you would expect normally. So this time it's given Thomas Christie fully. Maybe I'm doing this, giving this the wrong. Oh, Thomas Christ, yeah, that's me. Oh, dear Lord. It's funny, I sent a card to someone really important a few years back, and just for no reason at all, I wrote Happy Christmas, just because it came off. Anyway, okay, that didn't show what I was trying to show you. Let me try and show you what I mean. What generally happens is, that's what I was trying to show you. So it's taken, at this point, this is what I was trying to show. What's happened is, it's taken, I put in Thomas as the first name, it's accepted that as the first token, that's fine. I've put in Thomas Christie as the second, it's taken Thomas as the first token. The second token, it's taken the Christie, which is fine. And then, after the start again, this is what I was trying to show. I've asked for the next line, but as you can see, it's taken as 0 inputs, nothing. So it's skipped that input. And that's the point I'm trying to make, that when you were doing Python, most of you have done Python, I understand, or some other language, you know that when you press enter on the keyboard, the enter keyboard stroke, the character of enter, is actually a symbol that simply means next line, move down to the next line. So what's actually happened here is that every time it calls next, it takes the next word in the buffer, excluding the space or any other character after. And when it's taken in Christie here, this final one, it's taken in the word Christie, but it's not taken the carriage return. And then when I call next line, in this instance, it's taken the continuation from the end of Christie, from this Y onwards, which is the carriage return, and used that as an input. And that's what I was trying to showcase, and I hope that makes it clear that you have to be careful how you utilize next and next line. Most of the time, in my experience, what you're trying to do is take in the next line when you're doing coding. So when you're taking a user input, you can take the entire line of their input and then manipulate that how you want to. So if you want to split names and stuff, you can do that in a different way. That's usually what I found in my experience, that's what I mostly use. So I would advocate considering, just think about what you want the input to be like. Do you want it to be word for word for word? If that's the case, use next. If you want the input to be the entire string that's been typed in, use next line. But just be aware of that there is a sort of a difficulty or a conundrum, a problem that happens with the carriage return or any other white space when you call next line after next, because it doesn't take the next line, it actually takes the same line until it reaches the carriage return and then exits that way. Any questions on that, guys, before we move on? I can't really see, but yes, sir.
What can we do if we want to work like this? We want to print out the next line, and the last one is next.
Okay, it's a very good question. So yeah, what do you want to do if you do want to use this situation and then you do want to use next line after you've used the next? All you have to do is in your mind to be aware of that condition and then just take a next line without acting upon it. So dump it basically. So call next line just to clear the buffer and then start with your actual next line. Does that make sense? So that's how you would work that. Good question. Thank you. Okay, so I'll move on from there. That's pretty much the cusp of everything that we needed for last week, and I had a few questions over the last week about this, so I wanted to just highlight that. So today we're going to be discussing control. I always get a cough, excuse me, I'll go really far away. Didn't help, did it? Sorry. I get a frog in my throat when I talk, I don't know why. So today we're going to be talking about control statements. There's quite a few of them. We'll be looking at conditional statements and loops. And as a programmer, obviously, this is where you kind of do most of your work. This is where you make the program do what you want it to do. One of the things that I want you to try and do is to wear two hats, right? So when you're programming, you're the programmer, and your job is to understand the code and the syntax and everything that's happening inside. But then when you're running your code and you're looking at all the the different control sequences that you've put in there, and you're preparing to submit your work, etc., I want you to wear the hat of the user. So you want to look at it from the user's perspective. Just have that in your mind. It's a very subtle difference, but it's an important one to take into account. So the first thing that we're going to be looking at, as you would imagine, is the if statement. You will have seen an if statement many, many times. I'll give examples of how we construct different if statements and such on different codes throughout the lecture. But an if statement acts only when a condition, a Boolean condition, is met. So it takes in a Boolean expression, and if that Boolean expression is true, then it executes a statement. So the syntax for an if statement is just if, open brackets, close brackets, and inside there you put in your Boolean, whatever that condition will be. And then after that you put in your statement, remembering to exit with a semicolon. Now, if the Boolean expression isn't met, then the if statement is not executed. The parentheses, the brackets are required, so you must use those. And you can't use other expressions of like integer values and such. It has to be a Boolean. So if you wanted to use 0, for example, you'd have to say not equal to 0, which then returns a Boolean expression. So this little example here is a typical, very small, primitive if statement. So you have if x is less than 0, then x equals negative x. So what this particular statement is doing is simply inverting x. So if x is less than 0, then x is obviously negative. And then by taking x and then equaling x to a negative x, it's then making it a positive. So it's like taking the absolute value, I guess, in this instance. As you can see, this is on one line. Now, when it's a small if statement, it's no problem putting it on one line. But in reality, most of the time you'll want to have many, many statements within that if statement block. So if you remember in Python, you would have the block that was tabulated and lined down. In Java, that's not the same. In Java, you want to use these curly brackets. So when you want to execute multiple statements, you generally put everything that you want the if statement to execute on the condition within curly braces. Now, if I give just a quick example, if I just go here, I'll just comment this out so that what I propose to do, as you can see here, I have all the lectures and everything that I talk about and code will be in these lectures, and I will supply those to you for your revision, obviously, as we go along. So if I want to do a standard for loop, oh, no, it's not a for loop we're doing, is it? It's an if statement. An if statement. This is the basic if statement. If a condition is true, then open brackets, close brackets, and whatever's in between here, yeah, you can see that. This is what will be executed, right? So if we take an integer of x and make it equal to 10, and then we say if x is greater than 1, then we know x is 10, therefore this is true, right? So if this is true, we can just print yay, I don't know, something. So when I run this, you expect that system.out.print will execute because x is equal or greater than 1. Everyone agree? Yeah. Yep. And yay, we're successful. So it's a pretty basic explanation. Now, when you're using a different IDE or not an IDE, an editor, you don't need to have the curly brackets for a single line. So if I run this now, as you can see, I get the same results as is if I run this. Again, I get the same results. And mainly it's because Java doesn't care about white space. In fact, if I do this, It should give me the same results. I'm always nervous, you know, when I'm giving examples and I'm showing little things like this. Sometimes things change during the time that I learnt and what I'm showing, and sometimes you get errors, so I try and show you something and it gets an error. So every time I do things like that, I feel a little bit nervous because it's ad hoc. Anyway, so you can see that the white space isn't taken into consideration. So it's perfectly fine for you to do this, to have that kind of if statement, if you're just doing one line. But if you're doing more than one line, of course, you need to then consider other options. So if I was to... So I type in SOU out, so SOUT, system out, press tab, and it gives me a quick system.out print line. Yay, boo, I don't know. So if I run that now, what's going to be the output? Anyone? Somebody shout it out. Boo. Excellent. It is actually going to print out yay boo, right? But not for the reasons you would think, I think. So if I was to say, if I change this, if x is less than 1, what is it going to write now? Exactly, boo, right? Because boo is outside of the if statement. So if you don't use brackets, only the first line post the Boolean will be executed. In other words, only this line here will be executed, and this line acts outside of the if statement. Now, if you're using an IDE, and this is the point I was going to make, if you do what's called an auto arrange or something. So on my Mac, I basically hold Shift, Control, and press F. And it basically fixes the code. And what it means by fixes, it indents, does all the indents the way I like them. And it also adds brackets, even when no brackets are needed, because I want you to get into the habit of, even on a single line like this, using brackets just to be very explicit. This is what I want, this is what I expect. And this way there's no ambiguity, so you won't make the mistake like I previously showed with this one, looking as if it was inside the if statement. Now, if you're coming from Python, you would be forgiven for doing that exact thing because Python is that way, right? That's how Python works. But Java does not. So if you wanted this to print inside there, then of course that's how it would be. And in this condition, what's going to be printed? Nothing. Excellent. Wonderful. So far, so good, right? And I know it's easy when you're going through it with me now, but I expect that things do get, what I find is with the course, that things do get very difficult very quickly. So as much as this feels very simple and easygoing, hang in there because we're going up the roller coaster, right? And soon we'll be coming down. Anyway, so back onto this example, one of the things to also remember is that when you have the braces, so you've got, okay, this is the two examples I mentioned before. There's two types of programmers, some that do this way of putting the bracket on the same line, some that do it on a new line. I just happen to like it on a new line. It doesn't make any difference at all how you do yours. One thing to remember is that every single statement has a semicolon, so this has a semicolon, this has a semicolon, but of course the curly braces does not. Now, if you put a semicolon there, Java won't really pay much attention to it, but it's incorrect in it being a formality, right? It's not expected, so it's just it would just be a bit of an eyesore, I guess. So, looking at this example, you have if x is less than 0, x equals -0, system.out, x is negative. And the question is it negative? No, right? And the reason for that, and something to be aware of, is that in this case I have changed x before I've outputted. Exactly like you did in all the other languages that you've learned, if you've learned languages. Java is no different, that it follows each line of code from top to bottom, working its way down. So as it enters the if statement, yes, x is less than 0 because it's entering into it, therefore it is negative. But at this point, then it's taking x and it's making x equal to negative x, which if you negate a negative, it becomes a positive. So in this case, it isn't negative at all. Now, if you did want to have, if you did want to make this output as a negative value, what would you need to do? Perfect. Yes, exactly. So the first thing you need to do is to do the system out first and then change the value, right? So if you had a situation where you want to make sure that there's no negative values in your code, then you want to print out what the value is so that it's accurate. You know, x maybe minus 10 is negative, and then it inverts that. Make sense? So far, so good? Okay, excellent. So what's wrong with this? We've just gone through it. There's no brackets, right? So the x equals minus x is outside of the if statement. Everyone agree? Yep. So always use brackets. When you have, like I said, when you're using NetBeans, and I hope most of you do, just because it is free, it's very powerful, and it makes programming a breeze, absolute breeze. So there's no reason not to have it. Well, there is one reason not to have it. It's quite big. It's quite a big download. So if you've got very limited space, I can understand why you'd want to use maybe Eclipse is smaller, maybe JEdit or Notepad is even smaller still. But you know, go you if you're using Notepad, just because it's going to be a lot more. You'll certainly be a better programmer, put it that way, if you use Notepad. But you will be less efficient in terms of your output. But that's not a bad thing when you're learning. It really isn't. In fact, when I learned to program, as I mentioned before, I did have to use Notepad for the first year. So just the way it is. Things change, right? So the IDE will automatically put braces in if you ask it to. I don't know if it natively does. I don't know if NetBeans natively does that, but I'll do it on another lecture. I'll go through the way of setting the NetBeans up to get your preferences, or you can just Google it, actually. If enough of you give me questions about this, I'll run through it with you, but generally just have a look up how you change the preferences to have NetBeans output the way you... There's so many things you can change to make it look the way you want it to, including changing colors and stuff. So this was a possible exception, but I've turned my Netflix off not to do this, so I don't particularly favor this, just because in my experience, when I'm coding, I'll always want to add something to somewhere, and then it's easier for me just to have everything the way it should be, and then I just add something into the line rather than add. It's a very trivial thing, a very small, minor point for me in terms of adding a couple of brackets and then an extra line. But it does prevent me from making a mistake of thinking something's on a line when it isn't. But of course, that is an exception in the sense that it does look quite neat. It's very small. Something small is happening. And in this case, there isn't much ambiguity because it's on one line. Do you know what I mean? Makes sense? Anyway. So, much like other languages, you have the if statement, and you can have multiple if statements. And you can have if this condition, if that condition, if that condition, and you'll do a lot of that. But just like other languages, there's also an else. Now, Java doesn't have an if-else single statement. It has else, and if you want if, you then just do a new if, right? So you have if, else, and if you want an else if, you do else, and then you do if again. I'm trying to read what this is plotting out. So the example is, if you have if a condition, open brackets, do your if condition, and then else, and then give your other condition, right? If you want else to be a second if, then you simply put else and if there, so you put an if at the end here, not with a gap. I'll show you in a second. And this is a common way of sort of presenting that, right? So the brackets are required. You can't not have the brackets, and these brackets are optional if it's a single line. And that's true of an else as well. So if I was to say, if I was to do a situation like this, and then put else, I could put in that situation, and it's quite happy, right? It's okay, it's a single line, it's not going to have a problem with that. So again, that would print out boo because this one's been represented. If I was to put this there, you can immediately see that it's giving me an error. If you're using a notepad or something that wouldn't give you an error at all, you would just have to run the compiler and it would tell you there's an error in the compilation. And what it's saying is that it's not bracketed. It's kind of a semantic in my view, because if the compiler knows that that's part of the else, I kind of often think maybe it should put it in there automatically, but it doesn't. So when I do that, it's happy. And as you can see, you can combine the two as well. So you can have a curly bracket giving multiple statements and no curly brackets on the else as well. So it doesn't care which way it takes those. You can have them or not. But again, as I said before, press Shift Control F on a Mac. I don't know what it is. I forget. I used to know what it was on a PC. I haven't used a PC in about 5 years. But it's the same thing, something in F, and it gives you this formatting. And for me, I've set it to give me these brackets. Pretty straightforward. So, excuse me. I'm so sorry. Just get this frog. Again, you can use the more compact layout. Some people, in fact, I would argue that most people favour this one. I just don't, so you'll see me not doing it, and it's not a problem. Now, in terms of indentation, you've probably gone through this with your other languages. I would argue 4 is probably the norm, and I always do 4. 1 is too little, 8 is too much. Because you're going to be using a terminal, you're going to be using a Linux terminal to submit. Linux does have a limit to 80 characters from left to right in terms of how much it allows for output, so that the least tabbing that you do, the better. One thing about tabs is that each system that you run tabs on, so if you use a tab instead of 4 spaces, each system that you run tabs on actually offers, excuse me, a different amount of sort of spacing depending on the system. Sometimes you could have 2 or 3 letters, 4 letters, and then you press tab, and if tabs are set to say 8, it'll give you 4 extra spaces. Other systems, you put 4 or 5 letters and you press tab, and it will do another 8 spaces. So the rule of thumb is to use spaces rather than tabs. You don't see tabs any different to spaces, but depending on the environment that you're coding on. So if you're coding on an IDE like NetBeans, it automatically alters everything to be the same when you format the text. But then if you haven't done that and you provide it to someone who's running a different system on a Solaris system or some nano system, they're going to have different characters in there, and it may look very, very shabby, very messy. So the rule of thumb is if you're using the IDE, use the formatting. That should clean up any tabs. If you're using a normal notepad or something, the general rule of thumb is to use 4 spaces and to avoid using tabs altogether, just because you'll end up combining them and uncombining them and making a bit of a butcher's breakfast of your code. And in fact, last year I did have submissions because, okay, when you submit your main assignments, we do focus on code quality, the way that your code looks. Because Java doesn't care, what am I trying to say? Because Java doesn't care, the system doesn't force you to have your code in any particular order. So when you submit your code, we get the code the way our systems review it. And I've had some that have lost marks because they've been tabs where they shouldn't be, so their spacing goes out, and you will lose marks for that because consistency is what we're asking for. Consistency is an expectation. So if you're tabbing 4, not tabbing, sorry, beg your pardon, if you're putting 4 spaces within all of your indents here, then you'd be consistent with 4 spaces. If you end up putting 5 or 3, be consistent, right? You wouldn't lose marks for being consistent. But what tends to happen is that you'll do your code like this in your IDE, and then when you submit it to us and it goes on the Linux server, you'll end up having that. And yeah, the code runs, but you end up losing a mark just because of that, all because you probably mistaked a tab in there when you didn't really want to. So again, just pushing that home, don't use tabs, use spaces. Normally 4 spaces I would recommend, but if you're used to coding, if you're very good at coding and you have another preference, just be consistent, use the same throughout. And again, it's not that tabs are bad, it's just that sometimes when they are exported to a different system, they behave differently. And that's when we don't want you to lose marks. So, you know, tabs aren't bad. Don't go out of here going, oh my God, tabs are bad. It's just that, again, like I said, just be consistent. Whatever you use, be very consistent. And test it as well. Have a look at it on your computer, and then have a look at it on the server. Just run nano and the name of your code, and it'll show you the code, and have a look at how it looks. And that will give you an insight as to whether your code is looking the way that you want it to or not. So, going on the else if, did I just skip millions of them ahead? No, I didn't. So, the else if statement, as much as you'd expect, it's if you have an if statement, open brackets, that's how you do if from there to here, right? And close brackets. It's exactly the same as if you do an else, one or more else if, then you put the same statement that from that if to this close bracket is exactly the same here, so to have the second condition. You can have, obviously, an unlimited amount of else ifs, but you can only have one else, right? So when you have an else, it's just one else, because it's just one condition. You can have an unlimited amount of ifs independently, that's okay too, but again, just one else. So just to recap, you have if on its own is fine, if and an else is fine, if and an else if is fine, if and an else if and an else is fine, if and an else if, 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 else if is fine. As many as you want else ifs, one if, many as you want ifs, I guess, because it wouldn't really make a difference, they're independent. But again, one else with an if, just to be aware of that. And of course, you can nest ifs as well. So you all remember nesting? Nesting is where you put an if inside an if. So if I wanted this to be an else if, sorry, just to show you quickly, you'd have an if with a statement here. You could say x equals 0, remember double equals for a comparator. That's fine. That would run well. Gives you no output, of course, because it doesn't do anything. And then you could have the else, and then you could have some value here, value here. And the thing is, one else, multiple else ifs, although these booleans really shouldn't conflict. You want to make sure that the booleans are different so that they're not conflicting. That's another a condition, really. There you go, put that up straight. And that's pretty much it on if statements, really. It's pretty basic. Just remember that the if statement requires a boolean, not like in C it will accept a 0 or a 1 and things like that, but and other languages too. But in this it requires a boolean, and yeah, that's pretty much it. Looking at the time, I'm going to have a quick 5-minute break. Just looking at the time, let's have that quickly. Just to give you a chance to have a drink or a toilet break or whatever, and make it 4 minutes just so that we can move on. We've got quite a bit to go through, so.
So he, sorry, the main method. Oh, I had something here in mind. Yeah. Oh, yeah. So we're the main method. Yeah. I was taking an argument.
So why? Yes. Can I say ask
This is an array, right?
Yeah.
Do you know how an array works? Huh? Yeah?
Yeah.
So
It's an array, it's not string.
it's an array of strings. Right? an array string. So each element in the array is a string.
Okay, so what's the meaning of string and breaker?
These? This is defining an array. This is saying the type is array. This is. I think I went through it in maybe that's too long. I would expect. I mean, I can review it with you further. That's okay. But it is. We will be going into array later at that point, and we will go into detail of this. But for now, just understand every string that you supply to the runtime environment separated by a space becomes an element inside our array. So arrays are like a box of squares. Each square starts with 0, 1, 2, 3, 4 until the end, and inside each one can be a separate string. So it starts with 0, starts with 1, 2, 3, 4, depending on how many there are. I will review this later, don't worry, we won't be skipping it.
Okay, so what if you're looking for the comma and
well, if the comma was attached to Thomas, you can see it as a power of 1. The comma would the limits comma is just a charm. Take the charm as part of the original comma.
okay,
Yeah. Okay.
Yeah.
Okay.
Sorry,
That's okay.
Yeah, just a quick question for that simulation.
Yeah.
The question one, there's two common line arguments, right? Should we make assumption that the first letter of these two arguments will be complementary?
I'm not sure what you're asking me.
Like next way, for example, we're gonna say joy blow, right?
Yes.
Are we gonna assume that the both first letter of these two arguments will be in capital letter? I mean the first letter.
Oh, sure. Yeah.
Always.
Well, in this example, sure.
Yeah, but should
Yeah.
we make that one of the assumption?
Because it's an assignment, I have to allow you to interpret the question. But if the question specifies that,
Yeah.
then you must use that as an assumption.
All right.
That make sense?
Sure.
Yeah. Yeah. No worries. Thank you.
First, I have if I impose JavaScript and
That's a space equal to. Is two supposed to be parameter?
yeah,
Okay.
and I ask that if I need to move this into new line.
So you're calling in the Java virtual machine, you're providing a class called circle, you're passing in a parameter called num2.
Yeah.
Okay. And then your output is whatever your code is doing, right?
Yeah, this is the output, and I ask that if I need to move this into new line, which means I have to add a backslash in.
To be honest, I've forgotten what the question's asking, so I'll have to look at the question. But I would argue that look carefully at what the question's asking and the output that's expected, and divide that succinctly, because the output, the correctness of the output is what's important. Have I mistaken the question? Okay. Come and see me at the end if you need to. Okay. Just because I need to see the other people, and we need to finish quickly. I've got a lot to go through. But come and see me at the end. Yeah. Hello. Can I just do something? I can't see you. It's more for me. I can't see. Okay, you've given your name, yeah, and it doesn't take your password? Yeah? It doesn't show you. No, it won't show you. It remembers. Yeah, so do you have to just type it in correct, then it doesn't show you dots. That's a good point. No, you can. It's just not showing you the outputs. It knows the output. You have to just press the buttons, knowing that it's accepting it. It's a very good point. I should have mentioned that to the class. Thank you. Oh, okay. Yeah. Okay, thank you. I'll do that. Yes, I should have thought. Thank you. That's it. Okay. No, that's fine. I'm easygoing. I just want you guys to have the best experience. So I'll put them on. Yeah. I'll send on a gentle way, like this. Yeah. Thank you.
What version of JDK are you using with the
Whatever comes with it. I don't know off the top of my head. I tend not to can change it during the semesters, but if you have the latest, use the latest. It shouldn't be a problem.
But they didn't work. I told it to
have you got your laptop with you? We'll have to have a look at that. I don't know what to say. I've not experienced that thing myself. So if you bring your laptop to me, I'll see what we can look at and maybe fix it. It shouldn't. I mean, printfs are very elementary. They wouldn't change it too much. Let me see what we have and we'll work on that. Because these are very, very getting.
Alright, we're about to go. I just want to know, like, the way that we're going to add any element into the argument, is that the same for every IDA or?
Yeah, normally, but I don't. What IDE are you using?
IDEA.
Okay, I don't know this one, so I don't know the IDE, but they will. Yeah, you will have a run. There'll be an argument on. Just go to the properties of your project.
Okay. Because I didn't find any properties.
So you have properties, parameters. So my eyes, man.
Maybe I'll just figure it out by myself. Yeah.
Sure, but it will have it.
Sure.
I mean, it would be foolish not to, because it's an important facet of
Sure.
programs.
And also, like, my friend is asking me because the first person of the assignment again. So, if someone typing in the wrong way, like we're supposed to type in like the first letter always in capital, right? So, what if someone just accidentally say Joey, but all in small case? In this case, what if we add another line of code, convert the first letter of these two arguments into the capital letters anyway? Is that necessary or?
I'm not sure.
Not sure.
Well, I've got other. Let me review it with you.
Sure.
And we'll come to the details.
Yeah,
but
yeah.
I can't give you any information on the assignment anyway.
Sure, I know. It's only kind of like I don't know, like a semantic requirement.
Right. Can you see me at the end? Just because I really do need to continue, unless it's very quick. Go on then. Nice. I'm not sure. I can't off the top of my head. Okay, it looks messy, so you have to add. I would add it. Okay, sorry. Thank you. Okay, guys. Okay, so I've a couple of asks that I've had of the students. To leave the AVA lights on, just so that you can see a bit better when you're writing notes, that's fine. And also put this one on. I didn't realize it wasn't on, but thank you for that. If it's too bright, I'm sorry, do come and tell me, and hopefully it's okay with you guys. Okay, so we're going to carry on. We've got a lot to get through, so I'm going to start speeding up a little bit. It doesn't matter if the way that the lectures work is that there are areas that we can elaborate on more, and there's some areas that we can sort of quickly go over depending on the sort of the mood of the class and how much you understand. So that's part of lecturing. So don't worry, you won't be missing anything out. If I'm going too quick, do put your hand up and stop me. If I'm going too slow, tell me you're bored, and I'll move quicker. So I'll try and keep everything at a pace that is good for you. But we do have a lot to go through. The LSIFs are pretty self-explanatory, I feel. They're the kind of things that you'll have already covered in programming languages. Part of your prerequisites were that you understood a little bit, so that's why we can just sort of move forward, hopefully. If you do have any issues, do come and speak to me or speak to one of the tutors or the head tutor if I'm not available. Just a quick recap on the concept of ifs and else ifs. Braces, not an expectation, but I believe there's something that you should just use as a matter of course. It does make everything easier to read. So there's a concept called the ternary operator, and it's essentially an if statement that is kind of
a very tidy looking if statement that you sometimes use inline, right? And the concept is this, that you give a Boolean condition. So the Boolean in this case is, say, x less than y, right? And then after the Boolean, you put in a question mark. And then if the condition of x and y, if this condition here is true, then whatever's here on x is passed into the variable, or the condition is executed. And if it's false, this condition is executed. It is exactly the same as here. So you have lesser, you have this variable called lesser, that's already been initialized. So lesser, if x is less than y, then lesser equals s, else lesser equals y, right? So this is a commonly used shorthand way of putting an if condition or an if, the functionality of if into a single line statement where the kind of conditions are very basic. I will review something a little bit more complex later on. I won't go into it now, but there are ways to make this even more complicated. But for now, this is a very basic way. So the simplicity of it is, here is the condition. The question mark indicates that it's the ternary operator. And then you have the true value, a colon, and the false value, and semicolon. So that is the syntax, but you must load it into a given variable. So as an example, if you have, let's just say, a string, let's call it text, and equals. So we have x here. Let's give another value. Let's call it y is equal to, say, 5. So now we have the value x is 10, y is 5. And then let's just do that condition. So let's just say x greater than y. So there's the condition. Then you put in the question mark. You see the error is gone already. And then whatever you want to be put into the string. Now, because I've made it of type string, it means that whatever value I place here now needs to be of type string. So let's just say cool, then the colon, and poor. I don't know, whatever. So those values you've now got, if it's true, if this condition here is true, cool will be put into text. If the condition is false, poor will be put into text. It's pretty straightforward. It's not. It's kind of a very stylized utility of an if statement, if you ask me. I still tend to use the standard approach when I'm doing work for companies. You tend to get a feel for these things. Sometimes this does work very, very, very well, depending on the context. If you want to put it within brackets and do something very neat, then this does work. So if I was to, print that out, text, what will be printed out, ignoring this, of course. Sorry, somebody shout something? Okay, so it is cool. So whoever was shouting cool at the back, you're right, you're cool. So yeah, so that's another way of doing an if statement. It's called the ternary. It's I can't even say the word. Ternary. The ternary is in actual fact means 3 parts, and the 3 parts are the condition, the true, and the false, right? And whatever this then returns a value. So this has a return value which you store in whatever variable is equivalent to the return type. Does that make sense? Any questions on that? Okay. So again, that one line of code does exactly the same as that 1, 2, 3, 4, no, 5 and 6, 7 if you put these on central lines. So these 4 lines of code, right? Pretty straightforward. So now we're moving on to a switch statement. Some languages don't have a switch statement, but Java does. Some other languages do. I can't remember which do and which don't, to be fair. So the switch statement is simply saying that given a single condition, the condition being a value of some value, perform an action based on if that value is present or not. And you give a list of values, so you choose a switch statement. Normally you have a switch value and the case, so this expression here that's passed, whatever the value of that is evaluated in the case. If the case of that expression is true, then it provides a statement. Now, the switch statement requires you to use the break statement as well to terminate that one sort of statement of case. Now, if I show an example, so if you have a standard switch, again, I typed in SW and hit tab, and it basically puts in a very limited basic base structure template, whatever, of a switch statement. That's very useful. So this variable here is going to be a value. So we can say, let's just say int var, we'll give it some value, equals 10. So now that's value. And what you're doing here is you're giving it a value saying if it's actually 1. Now we can see it's 10. But just for a minute, just for 1 minute, just pretend that's variable, right?Maybe it's an input from the user, but we know it's 10. And we're saying, look, if you provide the variable, if the variable in the switch statement is 1, then you're going to do something. So again, this is 1, right? And you repeat this. I'll leave these bits in there for a second. I'll come back to those. So you repeat this with this being a different case. Maybe it's 5, maybe it's 10, like so. The values do have to be different. I will go through this with you in detail, don't worry. So the essence of what I'm doing is that it's like saying if this is the sort of rather than it being a Boolean, it's what's called a literal, the actual value. So if the actual value of whatever this variable here is 1, then do this, and you can put in multiple lines here, or you can call, sort of different things here, and it will continue running that until it hits break. Now, break is really important. If you don't use break, it will continue, regardless, looking through the code until it finds other values or goes through the end. So I'll run through the common errors in a minute, but so then once it has a break, it then exits the switch statement. Once it's found 1 value, it doesn't continue. It breaks out of the switch statement and then continues at the bottom. So it'll come to here, right? So you can have as many cases as you desire. So you can have 1 billion cases, that's okay. The condition is that you have switch, brackets, some value, some input parameter. Curly brackets are required in a switch statement, so you must put the curly brackets in. You then use the keyword case, followed by the value that you're going to be checking from the variable that's been passed, followed by a colon. Then you provide all the statements if that is the condition that's met. And then to terminate that particular switch call, you call break. And then this condition is repeated as often as you need to, with this conditional value changing accordingly. Now, it is normal to have some kind of sorted attribute. For example, maybe 1, 2, 3, 4, so on. But it's not required. So the switch case doesn't matter whether these are in order or not. You then also have a default, and the default is what's called. You don't have to have a default. If there's no default, so if this wasn't here, if it doesn't find, so let's say that this is 11, if it doesn't find the value, it just exits the switch case and doesn't continue. It just carries on with your code. If you have the default is run when no other value is found. So the default value will execute only if no other value is found, right? And the default value can be anywhere, or it doesn't have to be at the end, but normally, it's customary to put the default at the end. It just helps with reading. And this is the basics of a switch statement. Excuse me. Gosh, this frog. You think I was French? Sorry, bad joke. So since Java 7, you can even have this expression as a string, which is more useful. There are switch statements are sometimes, if you go on the forums, people reject the concept of a switch statement, saying that they're not favourable. I would argue that they are. I always use switch statements when using keyboard inputs. So if you want to press F for something, X for something, Control and V for something, I always use a switch statement. It seems so logical, it seems so straightforward. And because they're available in Java, consider them to be a normal attribute. I think there's kind of you'll see when you start looking into switch statements, they're often unloved, shall we say, and I'm not exactly sure why. So the cases, each of these values would be an int, a short byte or char, and also as of Java 7, so really what we're in now is 8, I believe. You can also have strings in there. And you can also have a situation where if you don't, let's say that you have, you want to evaluate vowels or consonants. So you want to know whether something was a vowel. What you can do is you can combine multiple cases to one block of statements. What does that mean? It means that, let's say in our example here, you have case 1. You may want to have, you could also have case 2, you could have case 3 and case 4. Nope. And then what this means is that I want you to print these out if case 1, case 2, case 3 and case 4 are provided. So it allows you to encapsulate a number of cases and provide the same output for those cases. Does that make sense? So that if you were having a vowel, you could put all your vowels here and then do whatever you want to do in reaction to finding vowels in this instance. And there's the other way as well. So the break is the important facet here. You don't want to be, you want to be careful that you don't forget to put the break in. If you don't put the break in, it would then continue to evaluate the next case and give you the next output, which tends to get very messy. So you want to really sort of enforce the breaking so that you break out for each case, unless you want multiple cases per one output block. But it's your job as programmers to enforce that concept, because Java won't force it on the IDE, and instead it will just give you weird outputs if you've got it wrong. But it is a common pitfall. So, as is just reviewing what I said, execution begins by evaluating the expression. It then looks for the case with the matching value. If it finds one, it begins executing with the next statement. It stops executing when it reaches a break or the end of the switch. And cases can be put in any order, but it is desirable to sort of have some kind of hierarchical or ordered values for your own benefit, so it keeps you sane, because you can miss things out if they're all in jumbled order anyway. You can have a default. It's not necessary, but if you don't have a default and it doesn't find the case, then it will just bypass the switch. A default will ensure that some code is run even if a condition is not found. And again, it's as I just mentioned. So, any questions on switches? No? Everyone happy? Excellent. Okay. So some pitfalls. As I mentioned, missing the break is a common pitfall. So you often will miss the break. It's easy to forget the break as well. And again, like I mentioned before. So let's just say if you're using NetBeans. And I would advocate, I know there's a lot of, if you're used to something, if you just type in SW tab, it automatically gives you the first value, you see, with with a break anyway. So it kind of enforces that if you follow the IDE's shortcuts, if that makes sense. Here's an example of a switch statement spelling out Morse code. So as you can see, you've got a case where it's a dot, prints out the word dot, then break. It's got a case, these are two cases. Now it looks the same. Oh, sorry guys. You can't see that, can you? You need to shout at me when I do that. Here's an example of spelling out Morse code. It's taking in the char. If it's a dot, it spells out the word dot and it breaks. If it's and if you look at this, these are different. They look the same, but it's it's very subtle. Oh, okay. You can see that one's a dash and the other one's an underscore, right? So you can see that there's two cases with the same output, right? So it's a dash, and that's what I was alluding to with the vowels. So you can have as many cases as you want, and it'll give the same one output. And then you've got a case of a space, which just gives a new line. And if it doesn't find any value on the dash dot Morse code, then it gives out just a bad character value and provides the character. Pretty straightforward, very, very simple. Any questions on that? No? Okay. So the next loop, as you will have used before, is a while loop. While loop is very much the same as what you'd have used with other languages. If you haven't used the while loop, obviously I will go through it anyway. So the form is to have the word while with the brackets, most important, with a Boolean expression, and then your statement. This would be a basic while, again on a single line with a semicolon would be needed at the end. The expression has to be of Boolean, has to be true for the while loop to be entered. If the expression is not true, then the while loop will be bypassed, right? So it won't execute it at all. Sorry. My word. So the loop will continue to perform the statement as often as is needed, well, forever, until the expression changes to a false expression. Again, like it is with Python and other languages, it's your job to maintain that the condition, this expression here, can be altered within the loop. Because if you, for example, just type in, hang on, let me just put that back in because I want to give you this code later. So if you just put in while true, and I think it's true like that, or is it true? I can't remember which one it is. If you put in while true and provide that as a loop, then the only way to break out of that loop is to actually use the break command. And it's considered to be bad practice to use a break command on a while loop. So the advice is not to run that. If I ran that now and had some output, oh my, then what's going to happen, obviously, is that it's just going to go into an oh my continuous loop without any sort of means or normal means to break out of that. So, and I hope that hasn't crashed up. There you go. Okay, so yeah. So this true statement here has to be maintained, basically. And normally you'll put in a condition there, some condition that you wish to evaluate, and that evaluation is continuously assessed each time the block of code within the while loop is executed. The while loop doesn't need to have curly brackets, but if you're using more than one block, just the same as you would with an if statement or any other loop, then you will need to encapsulate that in curly brackets, except for obviously just to harken back onto the switch statement, which requires the curly brackets nevertheless, regardless. So inside the while loop, you can have an unlimited amount of statements. You can do all sorts of manner of code, but the loop will continue to spin until the expression is changed. It's very common for you to go into unlimited loops whereby you do the counter the wrong way. So you start with, say, a value of 0, and you say, whilst this value of 0x is 0, whilst x is less than 100, keep doing the loop. But then you decrement the count somehow so that you don't end up having the statement can't be reached. Or another condition is, have I got it there? Okay. So another condition is whereby you say, keep going until the value reaches a given value, but then maybe by the way that you're cycling through those values or counting, or the counter's going, you bypass the exact value and therefore you don't get the exact change. Hopefully that makes sense. And again, it's best practice to put the while statements in curly braces. Again, the IDE should be able to do that for you. Here's an example of a typical while loop. So I'll avoid the boilerplate because we'll cover that in more detail later. You have an integer of equal to 1, an integer a limit equal to 10, and an integer sum equal to 0. And you're saying while I, which in this case is 1, is less than or equal to the limit, which is 10. In this case, I is 1. So therefore you add, this is the increment, sum plus equals I. So it adds 1 to sum each time and it increments I. Now, of course, if you didn't have the plus plus I or the I plus plus there, this would never exit and it would just go into a continuous loop. This particular output gives the sum of 55. And it's a pretty basic while loop. Any questions on that? Any questions? Everyone happy? Yep. Okay. So now, okay, so I've put a bit ly, so I want you to go to bit.ly, and I'll log in here. New poll. Oh. Why isn't this working? Update. Aha, okay. Okay, so I made a really shorthand. You can either put in bit.ly /T Christie. I think that should still work. Or you can go to quickpollunimob.edu.au.T Christie. And once you're there, the question is, what will this print out? So that's your question. So I'll give you a few minutes. Everyone got a decision? Have a guess if you can't work it out. I see a lot of you scratching your heads. You can see I anticipated that, can't you? Actually, the real reason that Homer's there is because in previous years I've accidentally shown the answer on the next slide. So to avoid that, I give an extra slide with Homer to tell me, no, don't go forward or you'll show the answer. Okay, so I'll give you 5 seconds to make your choices. 5, 4, 3, 2, 1. Okay, make your choice. I'm going to update it now and see if you've got it correct. Boom. So most of you are saying E. There's a few of you saying A and a few saying D. Now then, so the actual answer is in fact E. So well done, everyone who said E. I'll let you review that. What you want to do, now this is the kind of thing that you will definitely get, this kind of question in an exam. So what I would ask you to do for anyone who didn't get the answer quickly, just write it down on a piece of paper and follow the numbers and the loop on a piece of paper and see how the output comes. You should be able to find the output. Maybe works clearer when you're writing it down and you have a persistence of the paper in front of you. So well done. Okay. The next structure we're going to look at is the do while. Now, there's a slight semantic difference between a while loop and a do while loop. A while loop simply says, if this condition is true, do this 1,000,000 times until I say otherwise, or until the condition is not true. A do while loop simply says, do this, and then it says, I'll keep doing it while this condition is true. So a do while will do the statement once every time, and then loop It's a very useful feature, particularly if you're sort of asking a user for inputs and they give you the wrong input and then you've got to re-ask them. You can ask them for the input first, and then if the condition of that input isn't met, you can ask them again and again and again with the same code, right? So it's just a repetitive thing. And that's a very useful feature to have. The expression is almost the same as a while loop. Ooh, what's going on? In the sense that you have the do keyword followed by your, again, we should, in its actual terms, you'd have a curly brackets, right? I would advocate get used to curly brackets, but you have your statements, then you have the keyword while, open brackets, and the Boolean expression that you're going to be testing on each iteration. And again, it stops as soon as the expression is false, and it has to execute your statement once. So it'll always execute your statement once. And sometimes that's what you want, and other times it's not what you want. So the choice of whether to do a while loop or a do-while loop is dependent on what the requirements of your code is. But they both work the same in that based on a particular expression, they will continue until that expression is false. So they're both loops. The only difference is that a do-while will execute the statement once before it checks, and the while will check before it executes. Right? So sometimes the while loop will be bypassed. A do-while loop will never be bypassed. It's always executed once, at least. And again, it's best practice to put the statement in braces. So here's an example of a do-while. And you can see it's just the word do with the braces. Then your statement's what you want it to do, followed by while at the end, much like you do with the else. And then you give it the condition and followed by the semicolon in this instance. Make sense? Any questions? No? Okay. Give a little, let me just reset that for later. So if this is a do while on some condition, say whatever, I won't bother with the thing. You can do a do while. Again, is the same. So you can just put in some value. So that is the same. I don't know why that's giving me an error. Why is that giving me an error? Unreachable statement. Oh yeah. Okay. So what it's actually doing here is saying, look, you've got while true there. That's never going to finish, right? So I'm never going to get to this. This is going to kill me. Like, that's going to kill the program. So if we just said x equals 1, and then here we just say, x is already, no, x equals 1, you can't do that because it has to be, what have I done? It's already defined. There you are. It can be converted to a Boolean. Okay, so we can't convert a Boolean, so we'll say x greater than 1, greater or equal to 1. There you are. So now it's a Boolean rather than an assignment. So now this one's happy, and it's simply saying, look, again, it's giving the same rubbish, right? So this is not a good practice to do. This is just for an example, so that you can see that this is a Boolean, and that's the only reason I'm putting it as true. So it's exactly the same. These two will do exactly the same, except for this one doesn't say oh my, right? So essentially, the only difference, like I said, is that this will execute once, and this may or may not execute at all, depending on this condition, right? Or this condition would be the same. Does that make sense? Pretty straightforward. You will get opportunities to play with these in the labs, so don't worry about that. Oops. Okay, so the difference, just as I've expressed already, while executes the statement 0 or more times, the do while executes the statements once or more times. The while loop, if you need to check the condition, every time before executing it, and sometimes you do, right? You need to make sure that certain conditions are met before you run a certain amount of code. The do while, you want to run some code before you execute the loop, and you want to loop that code until the value is met. That's often used. I often use a do while when I'm asking a user for a username or a password, because I want to ask them for a correct password. Once, if the correct password isn't given, I'll loop, and I'll count how many times they do that before I kick them out and say that you don't know your password. So I'm not sure what it's talking about the limit here, so I'll just move on and we'll come back to. So we've had the if statements, we've had the while loop, we've had the do while loop. We also have a for loop. Most of you will have already used the for loop. It's one of the most common loops that you would use, and it's simply saying, like, for a given number of iterations, perform these tasks, right? So it's much the same as a while loop, but the initialization is done inside the for loop. Now, in Java, the for loop looks like the following. So all you have to do in Java is just type in for tab, and it gives you a for loop, a very basic for loop. And again, it's giving me the for while x is greater than 1. It's moaning that it couldn't get to it. What I'll quickly do, what I'm going to do is quickly just get rid of all these statements so that I can run this code. All I've done is used a block commenting symbol. Okay, so we have a for loop, and what's happening here? You've got the keyword for. Oh, a point that I haven't mentioned, and I should have mentioned early, and it's just dawned on me this moment. Keywords such as for, do, while, things like these, you can't use them as your variable names. So you cannot use keywords as variable names. So just be aware of that, and make sure that, you know, if you have an error to that extent, that's what you need to avoid doing that. Okay, so for loop simply has 3 elements. It has for a starting point, the initialization, a test or a condition, and an increment. So it's in 3 levels. Now, interestingly enough, Java allows a for loop that looks just like that. It just becomes an infinite loop, right? Because it just loops and doesn't know what to do. So the first part here is the initialization. The second part is the test, and the third part is how many times to update, right? So that's the basic creation of a for loop. And what will happen is, from this initial value to the test value, it will loop according to how many times it updates that many times. And in practice, this is a normal, so this is going to count from 0 to less than 10. Less than 10 will be 9, right? Which means it'll count from 0 to 9, which is actually 10 iterations. And it will do it in I++. So in other words, one step at a time, right? So if I was just to say, if I was just to say print I, you'll see that it just simply counts from 0 to 9, right? That's pretty straightforward. So this is the basics. Now, for loops are a little bit more complicated than that, but for the purpose of this class and what I will be expecting of you, this is the nuts and bolts of what I will expect. I will indicate some of the things that we can do with for loops, but in truth, this is what I expect. And of course, if you do another for loop, you can use the same I again, or if you do no, hang on. I wanted to put that inside. If you do you can do nested for loops, and of course you normally would use I for, so it's customary to use I for the internal variable counter, and of course if you have nested loops, then you increase that value, I, j, k, l, and so on. A key to note is that this int I is initializing the variable I inside the for loop. And what does that mean? It means that I does not exist outside of the for loop. So you can't print I after the for loop finishes. Does that make sense? So if you wanted I to exist outside, you'd have to initialize it outside the for loop. How would you do that? You would just say simply int I, and then you'd remove this. And now I exists outside of the for loop. A very simple, trivial change, but a big difference depending on what you want your code to do. Right? So that makes sense, right? So far, so good. Any questions? No? Okay. So this is just evaluating what I've just expressed. And a for loop is more, I would say that we use for loops more often than while loops. Well, maybe that's an exaggeration. For loops generally are more controlled than while loops in the sense, I use that term loosely, in the sense that you know exactly how many iterations that you're going to be providing the actual output. Whereas a while loop you don't know until certain conditions are met, right? So with a for loop you should know exactly how many times it's going to run without really running it. I think that's the point I'm trying to make. So here's an example of a for loop giving out the same output. Again, you have the limit and sum, and in this case it's exactly as I mentioned, but it's using, again, you can put variables in here. You don't have to use, like the example I gave here, I put 10. Of course, this can be a variable. This can be a call to a function, or method, sorry. I have to remember Java terminology, call to a method. I'll go into all that as we go along, but there's so many powerful things that you can use as you utilize these things. So this is just a basic adding up, accumulating the value of sum using I, exactly like we did with the while loop, but in this instance I is actually initialized inside the loop, goes up to less than or equal to the limit and increments. Again, as we mentioned before, the pre-increment or post-increment of the I, it has no real difference when you're just using it as a counter. As you can see, I asked NetBeans to do this for me. It uses I++. I've always used I++. I never use ++I. I know a lot of C programmers, and they tend to use ++I. I wonder if it's a C programmer thing. But it doesn't matter. That's the point I'm trying to make. It doesn't matter if it's ++I or I++. The bottom line is the counter will do the count if it's just used as a counter. So that's pretty much a for loop. I'm sorry. I don't know what it is. If you're listening on headphones, you're going to just be cursing me. Okay. So this is just going through the definition of what I was saying. The interesting thing about a for loop is, and this is what I was going to say, and I don't expect you to use this at all, is that you can actually feed. So you have, let's just put it back how it was with an int I here. Get rid of this I. You can actually feed multiple counters in a for loop and have them counting up, down in multiples of 5, 10, 20. So I could say int ij equals 0, and I could say int k equals 0 here. Let me just get rid of this one. And then I could say j negative negative, comma. And I could, should it be negative negative, and I could say k plus equals 10. I'm not sure why that's giving me an error. Identifier expected. Okay, I'm not sure why that's giving an error. And rather than chase the error now, let me see. Oh, it's that there. Nope, that's not it. So that's got a comma. That's got a comma, Okay, but here's one I created earlier, like Blue Peter. I have been working with this. I believe I've got one that I created earlier. Yeah, here's one that I created earlier. So this is what I was trying to create, and I'm not sure why that one. Rather than fight with that one and fight the error. So what I've got here is multiples of, oh, I see, yes, I see what it is. You can only initialize one, so I remember now. You can only initialize one of these inside. It has its limitations, so you can only, there you go, so you can only initialize one of those inside the, oh, they've already been initialized, have they? Inside the variable. Oh, no, yeah, of course, it's the type. That's one of the key points. Okay, I'll go back to the other example for the simple reason that it's got a lot more in there. So I'm giving it the type, and your typecast, that's one of the limitations, is that you're typecast. So if it's an integer, then they all have to be integers. So now I've got x, y, and z variables as integers. I'll come back to this one in a second. And then I'm incrementing these in different orders, right? So that's a very useful feature. I mean, you can use this in your assignments and stuff, that's okay, but it's not an expectation from me to you at this point. And then here, when you're giving it the condition, you have to use the and or operators to combine conditions together to enable you to have the correct conditions to be met. You can have X and Y as conditions, or just leave Z out, or whatever. You can have a combination of either or conditions to be met. Now, of course, this is quite complicated, and I think that this kind of utilization of a for loop, to me, makes your learning a little bit more difficult. So what I would implore is that we ignore, I'm just giving you that as knowledge, but for the purpose of our needs, we're going to just stick to the basics, which will be I is equal to whatever value you want, to I less than whatever value you want, and I plus plus. Right? This is what we're going to be sticking with really, and this is all we really need. But that feature is available to you if you become confident and understand it well enough to execute it. And that's what this, oh my gosh. That's what this slide is kind of giving you some information about. So you can use multiple initializations, updates and stuff by separating with commas. But again, for now, I think it's a little bit much in the sense that it's not something you will need to be using for what we're doing. But again, if you want to show off, by all means, show off as much as you feel is necessary. I'm happy with you showing off as long as you know what you're doing. I think that's the key. So any questions on for loops, guys? Any questions? Okay, I will just quickly jump into the, so we talked about break and continue. So if you want to break out of a loop, any loop or any nested loop, and you all know what nested loops are, where you have a loop inside a loop, you use the continue to skip a cycle, and you use the break to break out of the loop, right? But it breaks out of the innermost loop. So if I have a for loop like this, and I have another for loop like this, right? Oh my gosh. What I have, I'm conscious of time now. Nope. Oh my gosh. If I have this situation, and I run this, let's just run it anyway. So you can see it's counting various values in duplicate. So what's happening is, for every one loop of I, the loop of j is running 10 times, right? So that's what's happening there. So you're writing, it's doing 10 times 10, it's 100 times, it's running 100 times. That's pretty basic. But if I said, if I put a condition in here saying if j is greater than 5, then break, what do you suppose is going to happen? It's going to count up to, it's going to basically run this statement once j exceeds 5, right? So if we run that again, I mean, it's very hard. You can see that it's hit, well, you can't really make sense of the output, but just in logical terms, as soon as j hits 5, it executes break, and then it runs back to the for loop and then runs this again. So this is only counting up to 6, right? So it's running up to 6, and it's breaking. Does that make sense so far? Yeah? But one of the things, so if I had another loop, just to add complexity, so if I had another loop called k, and I did the exact same thing here, and just say, look, whilst that's 2, break, it's going to do the same thing. So let me just There you go. So you've got a nested loop inside a nested loop inside a nested loop. If I break out of this nested loop, it breaks into this nested loop, right? Oh, sorry, this nested loop. And then if you break out of this one, it breaks into this one. So far, so good? Yeah, it makes sense. So breaks out of the nested loop. However, what if you want to break out of all the loops? You want to get out of them all. You think, no, condition's met. This is the Superman condition. Well, the way you do that is to give a variable name. Let's just call it outer loop, like this. And you give it a colon. And you can see I've put that before the outer loop. And now, when I call the break, I can say, outer loop. So now when I call that outer loop, it breaks to this point. So it actually breaks out of that loop. So the break is conditional based on the actual variable. It's kind of a useful feature to have. It saves you having to do multiple breaks depending on conditions. So you can actually cut short a deep nested loop quite easily and quite quickly. In the past, I would have often used something called system.out, not println, system.exit. And system.exit, what system.exit does is it simply kills your application, just shuts it off and says it's stopped, halts, finished, finita. The 0 can be 1 if you want. That's just a value it returns. That value that's returned you can use for your further reference. So if you want to put different values there so that you can indicate why or where you were when it exits, that's fine. So any questions on that? I'm eager to. No questions? Yes? Yes, you can. Yeah, for sure. Let's run that. The output will look a bit numbery. I should have made it. So that's running that now. So what you can see is that the original. So this particular, good point. This inner loop started with 0. It ran that once. The first thing it did was print out 0. Then this inner loop started with 0. The first thing it did was print out 0. The second loop then, the inner loop again, the K loop, shall we say, started with 0, but checked the condition, and it doesn't print out. I'm not sure why that's given a 1, 2, 3. Can anyone give it a reason why that's given 1, 2, 3? Oh, yes, it's only running this whilst it's less than 2. So this one then runs. Printing 1, 2, and 3. I'm not sure why it's printing though, because I'm not printing it, am I? I'm not sure why it's printing, but it then system exit breaks before anything else is done. Still don't know why it's printing. Anyone idea why that's printing? So one of you really loud. Line 68. Oh, printing J, yeah. Okay, it's not a very good. I'll tidy the printing out for this so you can see the actual output. Very good question, though. Very good point. It's still throwing me at the moment. Again, this is live demonstrations, right? So. The point I'm making is system.exit is actually a termination, kills the program dead, stops it. This one, if that wasn't there, would have broken to the outer loop. So you would have probably got much the same output, but this time it's gone to the end, so you could have carried on from the end of that, like that. So you can see it's now carrying on the program rather than killing it, whereas if I brought that one back and ran that, you could see that it's now killing it, right? So there's a big difference there. Again, all these applications, I'll put them online. That's why I'm putting them in order so that I can give you the code to look at. Running on time. Okay, look, here's some pitfalls. I'm going to call it here just because I know there's another class going to be coming in very, very soon. So some of the pitfalls, we're very close to the end anyway, there's not a lot. I'll continue, there's only 3 more slides later. So I'll continue with this next week. If you have any questions, I'll see you outside, or come to me in the front as we move out. And remember, your assignment's due. The due dates are up there. Please make sure that you tackle the assignment. Make sure you get on top of it early. Make sure you get onto the network early so that you know. Quick point, guys. Do not leave it until 5 p.m. to submit your work, because the server will end up crashing, and it does. Okay, so just be aware of that. Submit early, submit often. Thank you.
Quick question about the,
yep.
all of the
let me
exercises.
Yep, let me just stop this.